In this video, I will explain to you how you can make a multifunction outdoor radiator, like this one. Okay, let's calm it down. There we go, so it's at a much more manageable level. Welcome back. This video will be about the outdoor radiator that is multifunctional and can be used for many different things, so let's get into it. Here we have our machine. Already has 4 radiators in it, but what I wanted to show, and the reason I made this, is so that I can keep the room cool during the summer. I can set sub-ambient or like sub-zero temperature overclocks in the winter time, and vice versa. So you can use this for many different things, and I will go over the parts as well. Right now we have the top 2 550 CFM each fans turned off, as we don't really need them. The only fans that are currently running are the bottom server fans, which one is disabled because it did eventually get killed by the weather. So yes, it does have some downsides, but we'll go over all of that in a few minutes. So what I normally have is these 4 fans, which are about 77 CFM each. Those are running at maximum speed and are not very audible. And the bottom server fans, which these are all connected with PWM, are actually the bottom server fan, one of the 4 server fans, it stopped listening to PWM signal, and I assume it's because of I think it was a wintertime situation where the server fan froze, maybe due to condensation and then freezing overnight, but I never got it to recover and communicate with PWM, so it would only run at full speed. So it's not actually disabled. I can resolder it, but it doesn't listen to PWM, so it's extremely loud. Right now, I think I have roughly 30% throttle on the fans. I have these set so that they just run at full speed because they're not that loud. And this is what it runs with. So it's a SATA connection, and I have all of these fans. So minus the 4 fans that I mentioned here, the regular computer fans, these are like Corsair fans. They run off of this, I think it's 10 output PWM controller, which is nice because it's direct power, and as you can see I have the sensor disconnected so that it's just giving full power. And then what I did with the bottom fans, kind of like what I did with the top fans, is I have the PWM 2-pin out connected to the splitter. I have direct connection to a power supply, so it's not running off of the computer, and this is all connected to the power supply. What this means is that this is just like a server power supply. I have the fan removed so that it is super quiet, as in there is no sound coming from it. Now it does have roughly a 10-12 amp limit, so I would like to add a switch there so I don't have to just unplug it and plug it in, but I don't have to run the outdoor radiator that often. But I did that, and it is dead silent. These fans are running at roughly 40% throttle, and they're dead silent. I have the pump set so that it's running roughly 45% throttle, and the machine is just dead silent, which is super nice. So what we have here is a PWM cable extension that goes to one of the outputs in the computer, and I have it set so that it's roughly 40-45% throttle. Now that gives the PWM signal to the top 2 fans, and it gives the PWM signal to the bottom 3 server fans. And if you disconnect it, so since it's direct power, it's soldered directly so that it's getting 12 volt. If I disconnect this, it gives the top 2 server fans and the bottom 3 server fans full throttle, which is, it will eventually overheat the power supply, but I have a couple other tricks that I wanted to show. So we have our whole 12-volt rail going out to a single output, and this has a bunch of connectors. I disassemble this computer setup quite often, and now this is just because I ran out of heat shrink, and that technically is a fire hazard, but it would just shut off the power supply, so do not worry about this. But basically what I have is I have two outputs, and these two outputs, as mentioned, run the bottom 3 server fans and the middle 4 fans. And then this big heavy boy is the top 2 fans. Now, this will overheat the power supply quite quickly if it's not running on PWM. And they are quite loud. Their bearings are designed for high power, not really being quiet. So I have this usually disconnected, but if I'm running some experimental stuff or it's super good wintertime experience, I'll have it plugged in. But on to the next part of the video. So, like I said in the previous part, I disassemble my equipment quite often, and water cooling is usually not something that you disassemble on a daily basis, but unfortunately I like doing that. Like, this is from a previous experiment with 2 150 watt heat sinks with a fan in the middle. The reason that's grinded down is because I was going to put liquid gallium in there to have a perfect connection, and it was just an experiment to see how much power or heat I could draw from the back end of the PCB. Not that there's any memory chips in there, but yeah, kind of like my speakers. I blow the tweeter mid-range, and only the best of the best speakers stay alive. So yeah, that's just kind of like what I like doing, is overclocking, heat soaking. On to the radiator setup. So this is a component per component upgrade as time goes by. Now, this bottom 480 millimeter radiator has been in place since, I think, January of 2022. I have taken the unit off and put it back on, but not for maintenance. It was just, I thought I was done with the outdoor radiator, and then you get used to the good temperatures and you just put it back on there. So the whole entire thing, which it does hold a lot of water, it may be roughly 30 or 40 pounds, is supported by these carbon fiber carbon fiber sheets that I cut, and they're directly connected to the bottom radiator. And with the angle, it doesn't put too much load on it, so like the load is that direction instead of down. But I've never had a problem with that. Now, I know in the comments I might get something about, well, if it falls, it's gonna pull on this, which actually before it was directly connected to the graphics card, and that was a problem because it would just kill the graphics card. Now I guess it wouldn't matter, but yeah. And then if I'm trying to maintain the computer, so if I want to do maintenance on the computer, or it's a LAN party, I have these quick disconnects. Now, these are super cheap. There's really expensive ones out there, and I couldn't find any cheap ones until I found these. I think it was like $25 for the 2 of them. But basically, I have negative positive, and then I have positive negative, so that I can just connect the computer to itself, and then it's a regular computer. And then I connect the, and they're no leak, so it'll drop a few droplets, but generally speaking, no leak. And then I just connect the radiator, and you get a few bubbles in there, but it doesn't usually mean you have to debubble the system. So we talked about the power supply, we talked about the radiator, and as a combination, I have the 480 millimeter radiator. It's double finned, but like regular profile. And then I added this recently. It's an XS PC radiator, so it's not a good radiator, but I just added it as more capacity. So basically just adding more water volume, well as just heat dispersion, because I have more than enough CFM here to do whatever I want with it. And then I have this Corsair double thickness 240 millimeter radiator, which is greatly appreciated by using these two 550 CFM each fans. So these fans are the most powerful fans I could find. They get the job done. They're even countersunk, so there's counter fins on the back. So basically, the whole entire thing is an exponential increase. So like they all cooperate with each other, but the sum of the parts is greater than each individual part. This is something I learned after just like putting the stuff together, that it's an exponential increase basically. So I will also show the weatherproofness. Now you can kind of see there's like a little leaf in there, the helicopter. Yeah, so this does get stuff stuck in there, but these are server fans, so they literally chop the stuff up. So sometimes I do have to put a leaf blower through here, but that's twice a year, and that's it. And a lot of you give me flack about what happens if it rains. It kind of makes me angry because there is a roof above it, and unless you have a hurricane going on, the angle of the rain won't get in here, but there you go. So nothing happens. In fact, I will turn this on. And it's already on. And then I'll even turn on the top two turbo fans. I'll even turn off PWM so it runs the whole 120 watts. Rainwater does not have any electrolytes in it, so it's not conductive unless you can deal with rust, which a PCB can't generate rust, generally speaking, and the bearings literally have oil in them. So yes, it is waterproof, yes. Now on to performance. Today is actually a pitch perfect day to show performance. I get a lot of questions about what do you do in summertime? Does it create condensation? We just tested the waterproofness of it. I mean, you could argue that it could rust over time, but I already have additional water displacement application on all the fans, so yeah, they're fine. And like I said, the radiator unit, at least the first part, has been in place since 2022, and I have not had any problems with it. So as far as performance goes, today it's not 70 degrees outside, but it's basically identical to the internal temperature of the room. Now computers do generate heat soak, so the heat that the computer displaces, since we don't have a jet engine to blow the heat generated to a further away direction, the radiators will start cycling the heat that they're generating. So the computer is basically kind of like the exponential efficiency of stacking radiators, which has been an experiment that I've been thinking about and doing for quite a long time. The computer, that's the basic problem with a computer. And in my room's very small, so my room will heat cycle, it will heat soak very, very fast. My heat capacity of this room is very bad. I have one vent, which means that even if you have the whole house cranked to 60 degrees Fahrenheit, this computer doesn't really consume much more than 600 watts continuously, but it will completely override the vent, which is behind the door, and the room is so small that the pressure just causes the vent to not really push any cold air. That has kind of been my challenge since high school, and that's kind of why this computer is the way it is. But let's go on to performance, and I will show you a couple things. Okay, so I do this in Fahrenheit just because most of my viewers are American. Actually, no, we'll just keep with Celsius. So 23.4, 23.3 degrees Celsius. We haven't run any big applications, so like the room hasn't been heat soaked. But 23.5, and right now outside is 23.2. So it's not cold outside. Now we do have to add in the factor that we poured water in there, so that's going to add some more endothermic reaction and add more exponents to that. So right now we have our PWM plugged in, so I'm not going to cheat. I'm not going to have it running at full speed. We have our PWM plugged in, and then we have our turbo fan plugged in, which is still running at the PWM signal throttle speed of, I think, 45% throttle. Now I'm going to plug this in. There we go. And I'm going to kill the internal fans. Now the internal fans, I have 9 of them, so they're all Corsairs. I think those are also like 70 CFM, but I have three on the inside because that's how I got everything to fit, and then 3 up here. I mean, sorry, 3 down here. So what the kill switch does is that it stops the heat from the computer to circulate in the room. I know I have the fans set really low, but we have so much heat capacitance, basically volume of water and copper, that I've tested this with higher fans, but basically this is the problem. Is now I have basically a 1-foot gap in the back, and this expels the heat, this pulls in air, and then this pulls in air, and basically that causes the whole thing to rise, and heat rises. So that's as efficient as I can get this system. I've tried reversing fans, putting fans in direction, and the internal radiators is, I have a 360 regular double fin, so it's, I guess, not a regular, but the CFM is so low that it doesn't really matter too much, especially after you get used to server fans. Regular fans, I know there's Noctua fans, they don't have enough static pressure to really make much of a difference. And then I added this 240 millimeter double stacker, so single row of fans, but it does have a double effect on there. So it seems to be working, but basically, argument wise, it's just more water and copper, so it makes the fan flow more effective. And then, so right now the water temperature is 26 degrees Celsius, and that's what it's been since this morning. I didn't open up the windows, and I thought that it was cold outside. I didn't go outside yet, and I had the outdoor radiator on with the turbo fan on, and it was still 26 degrees Celsius, and I was like, okay, what's going on? So I went outside, which is like, okay, well, I could have just gone outside or checked the weather app, but 26 degrees Celsius. So right now, you could say that we don't really need an outdoor radiator, but here's a very good test, and thankfully, the water temp is still consistent since this morning. The CPU is jumping around, but let's see here. All right, so I'm gonna restart the machine so we can get some baseline numbers. Let's do this. we go. Alright, we're back. Water's up to 28 degrees Celsius, 27, 26. Okay, so I'll read this off. I watched the previous video, the how to prep your machine for Cyberpunk, and I saw that the contrast makes it impossible to see core temp here because it's a white screen. Right now, our idle power is 54 watts, and our peak temperature is 61 degrees Celsius, which it's not a perfect application of liquid gallium on the die. I could have done a better job, I guess, but anyway, 61 degrees Celsius as it booted. So we're gonna run Cinebench R23, and we're gonna get some baseline numbers. So the water temperature is right now at 26 degrees Celsius. It seems like it's 26 and a half because it's jumping to 27. Now it's 28. So we're gonna start this. Now we're pulling 376 watts. We're getting 102 degrees Celsius. So we're still at 102 peak. Okay, so it finished. So it finished. So we have the hot core at 102 degrees Celsius. The second core is at 101 degrees Celsius. So we can agree that the general peak heat has been around 100 degrees Celsius. It's a very uneven application. It was kind of a rush job because we have some of the cores at 91 degrees Celsius, but still, the water temp hasn't increased. There's so much heat capacity with the amount of radiators and length of tubing that you can run Cinebench R23 quite many times and it shouldn't make much of a difference. But we're still at 26 degrees Celsius. And I'll screenshot this. So got that there. Desktop 26C internal. And that's basically why I don't really need to run the fans that much. But on the internal side, it doesn't really matter because like the goal is to get your peak numbers down. So 102 degrees Celsius is our benchmark now. So what we're gonna do is we're gonna check the temperature inside. Well, I'll end this part of the video and then we'll do a second part. All right, so I just goofed up on the previous attempt at recording this part of it. Right now we're going to check internal temperature and then external temperature, and it's about 0.3 degrees Celsius difference, which is an excellent time to test this project. So 23.8, 23.7, 23.6. All right, so 23.6 degrees Celsius, and then 23.2, 23.3, 22.6. Go. So 22.4 degrees Celsius outside, and this is an infrared thermometer, so distance exponentially decreases its efficiency at recording temperatures, so that's why I point it at the ground, and I point it at a couple different spots, but 22. Now this part I almost forgot to explain. Right now, I have the internal fans killed, and the way I did that is I have this switch, And the switch is connected to a distributor like this. So I have all 9 fans on the internal side connected to this, and I just I soldered the switch so that it's on the power side. And basically what you can do is, if you turn that off, the pump is still on. The pump runs on its own, but the fans are cut off. So what you can do with this is basically you can simulate a heat soak application, so you can get your computer to unrealistic amounts of heat, which is a good stability test. I've explained that a little bit on the Cyberpunk video, but right now the fans are killed and it is dead silent in here. I tuned the pump so that it is basically at silent speed. It's not audible. But for our test, we're going to turn on the outdoor radiator. So there we go, it's turned on. And now let's give it a few minutes to see if it causes any temperature change, since it does take time for things to cool down and water to cycle. So we're still at 26 degrees Celsius. I'm going to start a timer for roughly 5 minutes. There we go. And we'll see what we get for our water temperature. Hopefully it is similar to 26 degrees Celsius, because that should give us a good test for the Cinebench application. So as that's running, alright, we're down at 25 degrees Celsius. The reason I killed the fans is that if there's no airflow, the water loop is essentially insulated from the rest of the room. And what that does is that when you get sub-ambient temperatures, you don't really get much condensation until you get to super duper low numbers. So it's a great thing. So if you have a heater in the room, or you just heated the room, the cold air outside is still cooling the components to a great level, but you're not affecting the room's heat, which is excellent. Obviously, I don't have insulation on the computer, but it does an excellent job, and I've been running this type of setup since 2022, and it's excellent. So it's only been about 2 minutes, and we're already down to 24 degrees Celsius. Now, I've tested this system's efficiency many times. The graphics card is on liquid gallium. The CPU is direct die with liquid gallium. The memory is, instead of a thermal pad, there's thermal paste in place. So it's essentially the water temperature as well. Memory chips only generate about 5.5 watts of heat. But right now we're at 24 degrees Celsius, and yeah, the outdoor temperature was roughly around 21, 22 degrees Celsius. So having a water temp that is essentially the ambient temperature is insane. And like I said, it's taken me, I've been doing IT for 17 years. It has taken me quite some time to understand this stuff. But let's give it some more time, about 2 more minutes, and then we'll test Cinebench R23, and then we'll go on to some other tests. Okay, so we're down to 23 degrees Celsius. To reset these numbers, I'm going to restart the machine. There we go. temp is still hovering around 23, 24 degrees Celsius. Okay, so here's our test. Now again, the water temp really hasn't decreased. It's only about 2-3 degrees Celsius difference, but our number that we wanted to get was 102 degrees Celsius. So let's see. We're at 100. Still at 100. Okay, and we got 30,000 points. 30,000, 32 points. 2 degrees doesn't sound like much, but temperature is an exponential thing. Let me see here. 23, 26. Put this on the desktop. 24C external. There we go. All right. So that test is done. Close that. All right. On to the next part. So as you saw, especially when it's not cold outside, the outdoor radiator doesn't really do much. It's not going to give you some majestic, crazy numbers because it's not cooling the water any more than the air going through it. So what it's really effective at is, again, test the Cyberpunk. We're going to give this about 30 minutes. So we're going to give this about 30 minutes. I turned the internal fans back on. So we're going to run the computer basically as it is without an outdoor radiator. It's going to run for 30 minutes. And we're going to get some baseline numbers. We have RivaTuner statistics server up here. And we're going to see what the GPU and CPU is doing. I'm not going to move or play the game. I'm just going to have it idle, kind of like in the Cyberpunk video. And I do apologize. This topic is very conflicting in my head, but like I'm trying to explain it as best as I can. Okay, so now we have the same test. We're currently at 35 degrees Celsius. Now this is with a little bit additional cooling from the outdoor radiator from the previous test, so like the water temp is a little bit lower. But let's give it 30 minutes. So let's see. 30 minutes, and we'll see what numbers we have, and then we'll let the outdoor radiator cool down for about 5 minutes, and then we'll run the outdoor radiator for 30 minutes, and we'll check back on the temperatures. All right, we are back. 30 minutes have passed, and these are our numbers. So it's been consistent at 46 degrees Celsius GPU temperature. CPU will spike around, but around 60 to 66 degrees Celsius. So those, 67. So let's say here. Nope, can't do that. So let's see. Let me take a picture with my phone. And so we're at 47. So it looks like the delta high is 47 degrees Celsius. Let's just use that as our baseline. GPU temperature is pretty consistent. So 47 degrees Celsius. And now we're going to turn the outdoor radiator on. We're going to kill the internal fans and run it for 30 minutes and see what our temperatures are. Okay, so our 30 minutes is up with the outdoor radiator, and we have our temperatures. So I'm gonna post the picture at the end of the video as well. But here we go. So we have 46 to 50 degrees Celsius on the CPU, and we have 35 degrees Celsius on the GPU. So again, with the outdoor or the indoor radiator or indoor temperature being now 24.2 degrees Celsius, outdoor being 24.3 degrees Celsius right now, that is quite good. So I believe it was 47 or 46 degrees Celsius on the GPU right before we switched to the outdoor radiator. And that is, so let's see, calculator, I'll put this down, 46 minus 35, so that's an 11 degrees Celsius drop in temperature, while the water temperature right now, so I'll close out Cyberpunk. Wow, okay, so water temperature is dropping a little bit, but 26 degrees Celsius, so that's roughly around the same thing, but we have an 11 degrees Celsius drop in temperature. So that kind of is the magic of the outdoor radiator. Again, as the time goes by and you get closer to sunset, the air temperature is at its highest, but even so, we have an 11 degrees Celsius drop in temperature, which is excellent. So thank you for watching.